Convection.
Any discussion about energy on planet Earth would not be complete without a good talk on convection.
In a nutshell, convection is a form of heat. You got that? Convection is a way of transferring thermal energy. Convection is responsible for making things that happen on Earth happen.
Thanks for calling the Earth Science Hotline. What can I do for you today?
Every time someone tries to teach me about convection, I get this vision of a wounded unicorn in my head, and then I pass out. Am I crazy?
Let's start simple. Baby steps, you know? The key to understanding convection is remembering two simple things.
Number 1. Heat causes things to expand. Number 2. Hot things rise and cool things sink. Easy enough, right?
It's dying! The unicorn is dying! There's blood everywhere! Ah!
Girl, get a grip. Here, look at this soothing lava lamp. Just look at that wax. It goes up, it comes down. It goes up, it comes down, over and over. See? Don't you feel better? I do.
Janelle, are you still there?
Save the blood! Save the blood! Here, put it in my backpack.
Huh. Well, anyway, for those of you not having an existential unicorn meltdown, you should know that lava lamps are excellent examples of a convection. One thing goes up, another goes down, creating a circular motion.
More specifically, hot things go up and cool things go down. But why is this? Why do hot things rise and cool things sink?
It's got everything to do with density. Density is just the amount of stuff you have packed into a certain amount of space.
Like this cotton ball. When we stretch it out, it's still the same amount of cotton, but it's less dense and takes up more space. When we roll it into a little ball, it's more dense and takes up less space.
It's the same in the lava lamp. See how these bigger blobs are rising? That's because they have a lower density than the water around them. And these small blobs on the top are falling because they have a higher density than the water.
Wait just a second, weren't we talking about heat? How does that figure into all this?
Glad you asked. Let's look to the lava lamp for an answer.
See what happens when this little blob gets to the bottom of the lamp where the heat is? It expands. Get it? It becomes less dense.
Did you catch that bit of chemistry? Heat causes things to expand. In other words, heat causes the molecules of a substance to move apart. This makes them less dense and causes them to rise.
Meanwhile, when the expanded blobs reach the cooler area on top of the lamp, they contract again into denser blobs and sink back down.
And round that wax goes. Isn't it relaxing?
Wait a minute. Is this an educational show or what? I mean, we just spent the past several minutes staring at a lava lamp.
Have a little faith, will ya? We just spent the past several minutes learning about convection. You know, that whole hot stuff rises, cool stuff sinks thing? That's convection, and we've just been learning about it.
And believe me, it's been time well spent, because convection is the key to understanding many of the processes going on all around us on Earth.
Convection is responsible for wind, ocean currents, and even plate tectonics. And get this, by controlling the oceans and the wind, convection is behind weather patterns and temperatures on Earth.
To make a long story short, let's just say that convection is responsible for the global distribution of heat on Earth. What does that mean, you ask? Let's take a look at how convection creates wind and see if we can make some sense out of it.
All right, let's talk wind. First of all, what exactly is wind?
Wind is moving air. More specifically, wind is air that moves as a result of differences in air pressure.
We humans experience wind that's flying toupees or leaves blowing in those little circles. But wind is up to something way bigger than all that. Check it out.
The equator of the Earth receives more direct sunlight than anywhere else on the planet. That means the air there is warmer than anywhere else. Because it's warmer, that means it's less dense, just like those blobs in the lava lamp that became less dense as they heated up.
So what do you think this warm, less dense air does? It rises up into the atmosphere and spreads outward, of course. As it loses heat, it sinks down again and flows along the Earth back to where it came from, just like those small blobs sank down to the bottom of the lava lamp. Oh, so calming.
These circulations of air are called convection cells. When the air in a convection cell flows along the surface of the Earth, We experience this as wind.
Similar to the way convection generates wind patterns around the globe, it also generates ocean's currents.
Both wind and ocean currents play a large role in distributing temperatures around the planet, and they do it by convection.
Scientists also believe that convection is responsible for circulating geothermal energy back and forth between Earth's hot core and its cooler surface.
Convection here, convection there, convection in your underwear. Underwear. Your underwear. Pack it in. Convection in your underwear.
Our work here is complete. Thanks for watching, peeps. Ciao!